Hello and welcome to Classes with Atish. Today we will be solving some problems in kinematics. Mostly I'll be taking up problems from past competitive exams, specifically IIT Main and IIT Advanced. Before you play this video, make sure you revise the Kinematics 1, 2 and 3 courses. It's a refresher. We don't go into too much details in those courses, but it will tremendously help you understand how we are solving these problems. With that, let's get started. I will have the first problem on the screen. It says a ball is thrown upward with an initial velocity v0 from the surface of the earth. Okay. Initial velocity v0. The motion of the ball is affected by a drag force equal to m gamma v square. Okay. So a force is acting in the downward direction because it's a drag force, m gamma v square, where m is the mass of the ball, v is the instantaneous velocity and gamma is a constant. Time taken by the ball to rise to its zenith is. Okay, so this is not the only force that is acting on the ball. We know we also have another force that is acting, which is the gravitational pull, which is mass times g. Okay, so the total force acting on the body, we can say, is minus m gamma v square minus mg. We know force is mass times acceleration, so we can write this as m gamma v square plus mg if we take out the minus outside of the bracket. So the acceleration is minus gamma v square plus g. Okay. Now, can we apply the equations of motion for constant acceleration case, namely v equals u plus at? Because the problem here is to find out what is the time taken by the ball to rise to its zenith. But remember, those equations of motion were for a constant acceleration case. Is this a constant acceleration case? Well, gamma is a constant, g is a constant, but v, which is instantaneous velocity, is not a constant. So we cannot apply the equations of motion for constant acceleration case in this case. But we know acceleration is nothing but rate of change of velocity. So dv dt is minus gamma v square plus g. Alright? Okay. Now, if we rearrange this as dv and we bring minus gamma v square plus g here, and if we take time that side, okay. Now, if we apply an integration, minus dv gamma v square plus g, and this will be dt. Now, what would be the range of velocity? The initial velocity was v0. At the topmost point, the zenith, the final velocity will be 0, right? And if we say at time t0, the ball was thrown up, and the total time it took to reach the zenith is capital T, so this is what it is. Now, this side of the integral is easy, it is time, so t minus 0, so total time is the solution for v0 to 0 minus dv by gamma v square plus g. Or we can write this, if we invert the ranges 0 to v0, then we can get rid of the negative sign, so it becomes dv by gamma v square plus g. Okay, so all it remains to do is to solve this integral. Alright, let's see how we can solve this. Okay, now if we take, let's say, 1 by g common, because it's a constant, we can write it outside the integral sign. So this becomes 1 plus gamma by g v square. Okay. Now let's do a substitution here. Let's say u square is gamma by g v square. Okay. So this means u is root gamma by g v, or du is, because this is a constant, root gamma by g dv. Okay. Now let's substitute. So before we do that, we need to substitute the value of the range as well. So when v is 0, what is u? U is also 0. When v is v0, then u is root gamma by g v0. Okay. Now let's do the substitution. So this is 1 by g. This is 0 to root gamma by g v0. We can write dv as root g by gamma du. Okay, and we can write gamma by g v square is u square. Again, this is a constant, we can take it out. So we can take it out. This becomes 1 by root g gamma, integral sign 0 to root gamma by g v0, and this looks familiar, du by 1, let's write this down, du by 1 plus u square. Integral of this is tan inverse u, right? So this becomes 1 by root g gamma tan inverse u, where u ranges from 0 to root gamma by g v0, or we can write the result as 1 by root gamma g gamma tan inverse root gamma by g v0, and tan minus tan inverse 0, tan inverse 0 is 0, so the total time taken to reach the zenith is this. So which means the correct option is answer B. Okay. Okay then, let's move on to the next question. A particle is moving eastward with a velocity of 5 meters per second. Okay, so we know this is north, south, west and east. So particle starts moving eastward with a velocity of 5 meters per second. In 10 seconds, the velocity changes to 5 meters per second northward. Okay, so something happened, the velocity changed, the magnitude remains the same, but the velocity changed to 5 meters per second northward, and all of this happened in 10 seconds. Okay, the average acceleration in this time is, okay, very good question. Let's apply some vector principles here. So let's say we know the change in velocity, if it's a vector, is the final velocity minus the initial velocity. Okay. What is the final velocity? The final velocity is, if we draw a vector, let's say we call this final velocity is upward direction. Okay, initial velocity was in this direction, vi. Now if I have to do minus vf minus vi, So we can say we can reverse the direction of Vi. So this vector becomes minus Vi. Okay. Now it is a question of addition, minus Vi plus Vf. What is the resultant vector if we add two vectors? The resultant vector is this. So this is delta V in the northwest direction. That's important to understand here. Now everything else becomes easy. So if this unit is 5 and this unit is minus 5, then magnitude of delta V is how much? Is 5 square plus minus 5 square, root of that. Okay. So this is 25, this is 25, so root 50, or we can write root over 25 into 2 and we can bring 5 outside, so 5 root 2 in the northwest direction. Okay. Alright. So what is the average acceleration? Is the change in velocity divided by the total time for that change. So this becomes 5 root 2 and the total time for the change was 10 seconds. So it is 5 root 2 by 2, or we can also write 1 by root 2. Unit is meter per second square and direction is northwest. That will be the answer. So this is the answer. So if you look, the answer is C. This came in 1982. Okay. Clear enough? So this is more of a problem of vector addition slash subtraction. If we understand vector principles, then this is an easy problem to solve. Okay. Okay, now let's look at the next question. So this came in 2019 Main IIT. A particle moves from the point 2i cap plus 4j cap meter at t equals to 0 with an initial velocity of 5i cap plus 4j cap meter per second. It is acted upon by a constant force which produces a constant acceleration. What is the distance of the particle from the origin at time 2 seconds? So pretty standard question. So the initial position of the body is 2i cap plus 4j cap meters. Okay. Initial velocity, let us denote that by v0, is 5i cap plus 4j cap. 5i cap plus 4j cap meter per second. Okay. It is acted upon by a constant force which produces a constant acceleration. So it's a constant acceleration case. 4i cap plus 4j cap meter per second square. What is the distance of the particle from the origin at time 2 seconds? Alright, so the change in displacement, as a vector, is, we can say, ut plus half at square. Okay, u in our case is v0. We can actually write that as v0. Okay, so v0t plus half at square. It says time at 2 seconds. So let's say if we replace 2v0 plus 2 square is 4, so 2a. So 2v0 is 5i cap plus 4j cap plus 2a is 4i cap plus 4 j cap, and the unit will be meters. So 10 I cap plus 8 I cap is 18 I cap, plus 8 j cap plus 8 j cap is 16 j cap. Now we can say that this is final position of the body minus the initial position of the body. Initial position of the body was r0. So rf vector will be this plus r0, and r0 is 2i plus 4j, so I'm not going to write all the steps. Plus, so we can say 18 I cap plus 16 j cap plus r0, so plus 2 I cap plus 4 j cap. Okay, so this is nothing but 20 I cap plus 20 j cap. Now what is the distance from the origin? It's nothing but the modulus of the final position, and we know modulus square is 20 square plus 20 square, these two. So 400 plus 400 is 800. So RF is square root of 800. So 400 times 2, so 20 root 2 meters. So this is the answer. Okay, so 20 root 2 is option B. Okay. Okay, now let's look at the next question. From a tower of height h, a particle is thrown vertically upward with a speed u. Okay, let's say this is a tower whose height is h, and a particle is thrown upward with the speed u. Okay, so what will happen is it will reach a certain point where its velocity will become 0, then it will start to go down. At this point, exactly because this is a motion under gravity, it follows a certain symmetry. At this point the velocity will be exactly u, but in the opposite direction. But however, now it will not stop, but it will keep falling till the time it hits the ground. Okay, what does it say? The time taken by the particle to hit the ground is n times that taken by it to reach the highest point of its path. Okay, let's say the time taken to reach highest point is t. So with this, the equation of motion we can write is v, which is 0, is u minus gt, or t is equal to u by g. Okay, so this is first thing. Now the total time taken is, let's say the total time t, it says is nt. Okay, so we can actually make it simpler. Should be nt. Let's look at this part of the motion now, starting here and ending here. Okay, we know the distance traveled is h. Because it's in the negative direction, we'll say minus h. So we are actually applying the equation s equals ut plus half at square. Okay, so minus h. So minus h is minus u, whatever this time, let's say taken is t1, so u t1 minus half g t1 square. Okay, now we also know the total time t is nothing but, it will take small t time to reach the zenith, It will also take small t time to reach here, so 2t plus t1. Okay. Now t is nt, right? Is 2t plus t1, or t1 is nothing but tn minus 2. Okay. Now if we replace this here, so that becomes minus h is equals to minus u t1, so tn minus 2 minus half g t1 square is t square n minus 2 square. We can remove the minuses, I don't know why I kept those, but h equals ut, t is u by g, n minus 2 plus half g, t is u by g, so u square by t square, n minus 2 whole square. Okay, so this becomes u square by g square, n minus 2 plus half, this also becomes u square by g, n minus 2 whole square. Now if we multiply with 2g both sides, it becomes 2gh equals 2u square n minus 2 plus u square n minus 2 whole square. Okay. Now if we simplify this further, if we take n minus 2 common, so it becomes 2u square plus u square times n minus 2, so u square n minus 2u square. So 2u square gets cancelled. This becomes u square n into n minus 2. So the final answer is 2gh equals to n u square n minus 2. I think this is one of the options here. So 2gh equals n u square n minus 2. That is option C. That's the correct answer. Okay. Next question, let's look at it. So it says a small block slides without friction down an inclined plane starting from rest. Okay. So an inclined section, a small box starts sliding from rest. Okay. Let Sn be the distance traveled from t equals n minus 1 to t equals n. Okay. So distance traveled from t equals n minus, so let's say nth. So distance traveled from t equals to n minus 1 to t equals n. So basically distance traveled in n seconds minus distance traveled in n minus 1 second. So we're actually familiar with this. This is what we call the distance traveled in the nth second. And if you remember, we had a formula for it, and that formula though applies for constant acceleration case. Now is this a constant acceleration case? Yes, it is, because the only force that is acting here is a component of g in this direction, right? It doesn't talk about any friction or anything. So yeah, it says without friction down an inclined plane. So only force that is acting upon this is the component of g in this direction. Okay, so this is a constant acceleration case. So for a constant acceleration case, the generic formula for the distance traveled in the nth second is u, which is the initial velocity, plus a by 2 to n minus 1, right? Okay. Now for us u is 0 because it started sliding. We have the formula for s nth is a by 2 2n minus 1. So what will be s, because we have to find the ratio of s nth n plus 1th, right? So it will be just replace 2n as n plus 1 minus 1. So this is a by 2 2n plus 2 minus 1, or a by 2 2n plus 1. So the ratio Sn by Sn plus 1th is 2n minus 1 divided by 2n plus 1. So there's the answer, quick and simple, which is option C. Okay, the last question for today. A particle is moving with speed v equals b root x. Okay, v equals b root x along positive x-axis. So only direction is it's motion in one direction. Calculate the speed of the particle at time t equals tau. Assume that the particle is at origin at t equals 0. It's pretty simple, right? Let's find out what is the acceleration. Okay, how to find out the acceleration? So it will be dv dt is acceleration, or we can say dv dx times dx dt. Okay, now dv dx is b half root x. Okay, and what is dx dt? It's nothing but v, velocity. Now if we are able to replace the value of v with b root x, so this b is here, times b root x divided by 2 root x, then root x gets cancelled out, and this becomes b square by 2. Now b is a constant, 2 is a constant, so we can say this is constant acceleration. Okay, that's a big one, because now we can apply the equations of motion for constant acceleration case. So the question here was calculate the speed of the particle at time t equals tau. Okay, so the final velocity v f is initial velocity vi plus at, right? At time t equals 0, at t equals 0, x was 0 and velocity v initial was also 0. So we can say this is just 0 plus at, and a is b square 2 by 2 times t, and our question is what's the speed of the particle at time t equals tau. So the final velocity is b square tau divided by 2. So which is option B. Okay, so hopefully this helped. We will solve more problems in kinematics next. So these are some of the problems where we were able to apply the concepts and the shortcuts that we learned in our lessons earlier. So if you want, you can revise those lessons again. We will solve more problems in kinematics in later classes, but hopefully these problems help you in understanding the concepts a little bit more and see how you can apply those concepts and those shortcuts that we discussed in our lessons on kinematics.